Hi, it's Gadget UK here again, back on the carpet just now, and that's just because I've got an Atari 800XL on the bench at the moment. So this power supply is apparently faulty. It's one of the light ones, you know, you can pick it up with one hand and it just feels really light. It's not the one of the more linear ones that had a giant, huge transformer. You can see the part number there, it's the one that's rated 4.3 amps I think on the 5V rail, 1 amp on the 12V rail, and 0.1 amp on the minus 12V rail. So I think we'll start by just plugging this in, switch it on, just seeing what happens, see if we hear any sounds. It's obviously got some tape here, so I'm not really sure what's happened there. We'll plug it in, we'll measure the voltages there. It looks a bit dirty and oxidised, that. So apologies, it's a wee bit dark here at the moment. Yeah, a nice tip I learned from Jan Beta is a piece of heat shrink like that. You can obviously put your probe in there, make a connection to the pin without shorting to the sides here, but just like measuring every combination. I can't remember exactly what the pin out is here. Yeah, you might just be able to see the meter down there. There's like nothing in any combination of pins here. I've gone around pretty much all combinations there. I will look up the pin out of that in a minute just to be sure, but it's completely dead. So at this point I may as well just well, I'll check the fuse on the plug and then we'll tear it down. So on UK plugs like this, that's easy to do because you've got the fuse here in the plug. You can just pull that out. Meter on continuity test, so we'll bleep if they are put together. Let's just see if the fuse is okay. Yeah, the fuse is good, so it ain't the fuse. Yeah, so the fuse goes through the holder like that, and then back in. So yeah, let's get inside it. Right, so I should be doing this on the bench, but as I say, the Atari is consuming all the space just now. So let's just get the 4 screws out, just see if we can see anything obvious from the top side, and then yeah, the bench will be freed up, and we'll go back to the bench. Anyway, let's just take the lid off. Make sure it's not plugged in when you take something like this to pieces, whatever you do. Yeah, there we go. So straight away, look at that. That's not good, is it? And you can see the heatsink on that transistor there is pretty much shorting onto the that resistor down there. It's just, yeah, we'll straighten that out in a minute. Don't see anything obvious here at this stage. Well, look, crack down there. My guess is that's going to be something to do with the problem. It might not be, but yeah, nevertheless, it has suffered an impact down here. You probably patch that up though, it's just one of the screw mounts. In fact, the one down here, they've all sheared off, every one of them sheared off, look. All of the screw mounts are sheared off. Oh, that is a blooming nightmare. Let's try and pull this out. Let's have a quick look on the underside. So yeah, they are only the mounts, there's no connectivity gone there. So yeah, I can fix that back, I can fix those. I'll show you some techniques of sticking that back on just to help secure it inside. Look at the length of that component there, that leg, that's crazy. From factory. These are suffering from the standard, in fact I can see the problem straight away, dry joints. These dry joints here. Let me put you on macro. It's blatantly obvious the connections there which are on the transformer. They've got dry joint, dry joint, dry joint, dry joint. A couple of dry joints here where it's a bit black and charred. Yeah, this is the point where, be careful. Look at the flexing in that board, can you see that? See how warped that is? Yeah, it's incredible. So it's going to need some work to straighten it out slightly, that as well. But I think we can get this up and running, assuming the transformer's not balked. Right, we're back on the bench. That Atari is cheesing me off at the moment, I can't find the fault with it. So yeah, meter on continuity test here. Let's just check the fuse here. Some of these wires are right in the way. Right, so I put the wires on the bench just so I don't accidentally plug the thing in. And if we just test that fuse, it looks fine. You can see it's a big solid connection there, so it ain't that. Let's just test this choke here. If you saw previous videos on these, you'll know that this can sometimes go open circuit. So that's correct that way. One's going to be for live, one's going to be for neutral. They might be the other way around, don't take it as read as that's the orientation. No shorts either way that way. So that means there's no short around the bridge. You can see the diodes here. So there's going to be a bridge of 4 diodes which rectify the AC coming in and convert that into DC. So that's these diodes here. Let's just check these on diode test. I'm just doing them one way and then the other. That diode's alright. That diode's okay. And just so you can see the meter there, you'll notice that way, nothing. that way we get a forward switching drop, voltage drop. So yeah, there's no issues there. If you had a short here, yeah, you'd be wanting to check these diodes, replace them perhaps, but also the switching transistor, and there's going to be a capacitor there. Those are the sorts of things that could short, but the 4 diodes are alright, so the bridge is alright. We've got some dry joints there. I'll show you these in a minute on macro. And I think that is the issue. So the next thing is the switching transistor. Obviously in a visual inspection, perhaps a visual inspection at this point is where you should be focusing. Got that sharp there. Yeah, being careful to keep your fingers away from the underside of any charge caps. That could hold, let's just check that, could hold high DC. Because 240, 250 volts here in the UK, when you rectify that, you get like approximately 337 volts, I think, DC in there. 1 volt, minus 1 volt, look. Yeah. If there was a voltage there, you could just get some pliers that have got an isolated handle and just short. A better way to do it is with, I don't know, a 10 ohm resistor or something, a big wire wound one with a wire, and make sure you're not touching any of the contacts. I think we'll just trim that leg off there, because you know what, I don't like that leg. It's just crazy long. And we're going to trim these down as well. That's probably the switching transistor. Yeah, it is. We don't need legs that long in something like this. And obviously do make sure the bits don't join anything up anywhere. So yeah, that's those. I mean, technically there are a few more solder points I would cut down before considering this complete. But anyway, there's a lot to do on this, isn't there? It is bin fodder. When you see this data, there's look at that curve. It's crazy. But you know what? With some pressure, just gradual, slight pressure, that warpage could be straightened out. It's the copper. Yeah, the actual PCB is warped because it's been dropped or something. You can tell it's it's had an impact. So yeah, this wheel is malleable. In fact, did you see that then? It's moving over the pin. It's moving over the pin. I think someone's thrown this in a skip. And if you're wondering what a skip is, it's a trash thing. One of those giant, what do they call them in America or elsewhere? A trash bin. A giant bin, like a communal one. Recycling centre, and that's why it suffered all this warpage and the contacts here shearing off the edge. So yeah, if you're just careful, you could certainly use some heat as well. Maybe you could massage this almost back into almost straight. It's a bit straighter here now, but there's still a massive curve up here. This is a problem, so that needs straightening out. So let's just try and bend that, so we can bend the transistor backwards a bit. In fact, it's the heatsink more than anything. Just straighten the heatsink out a bit. Strange how that's almost been that way from factory, tilted over a bit. This is where I perhaps shouldn't have cut those legs down completely there, because if I strain them out a bit, I would be able to straighten the heatsink out. Anyway, we'll do that in a minute. Let me just put you on macro and show you these points here. Alright, so you're on macro. Hopefully that's going to focus. I'm not sure that is focusing there. But yeah, these solder points here, they're absolutely shot. Obviously those need reflowing because they're dirty. But yeah, I think you can see there's some bad solder points on that transformer. And yeah, I'm not sure if I showed you, but as I was moving the board there, the transformer's coming off. Look, can you see? It went up and down. It's detached itself. This is why this is not working. There may be something else wrong with it, but I don't think so. So another obvious thing to check here is, again on continuity test, let's just test the switching transistor here. Just for shorts. If there was a short, a fuse would have blown or something, so there ain't going to be. Yeah, all 3, combinations, or more than 3 combinations actually, because 3 pins. But yeah, no short, so I do see a couple of diode readings there that make me lead me to believe that transistor is okay. And actually, I think what I'm going to do is start with some heat. I'm going to heat this board up, see if I can straighten it somewhat. I only go in low temperature here, like 150 degrees. Just warm enough to, you just get this really hot, get the board nice and hot. Certainly at the point where the warpage is, which is sort of here, isn't it? Because one of the things here, it's not just the plastic, it's not the plastic necessarily that's warped, but it's about the metal. These copper contacts here, this is where a lot of the structural stability comes from, if you like. It's not just about plastic. So just by virtue of heating this, in fact I can see it straightening up now on its own. Yeah, just by virtue of heating this at the various points where it's got a bit warped, it will start to straighten out somewhat. And obviously as we solder some of these points, you can see that's looking straighter already. As we solder these points here, it's going to help hold it in place. But again, it could be then a source of a failure because the board is kind of like wanting to pull itself away from the point you've soldered it on. But I mean, already I can feel like it's starting to straighten out. Hopefully you can see that. Yeah, I think by the time that's soldered down there like that will hold it a lot straighter. Because that is so much straighter, look. There's just slight warpage here. When that's soldered down like that, that's just going to hold in place and it's going to be pretty much straight again. So I'm just overhanging slightly here, just so that the transistor there is not sticking upwards, because there is still a wee bit of warpage there. So this would have been manufactured with solder containing leaded solder. So yeah, let's just add some solder to each of these points here. I'm going to press the transformer up and strain the board as we do this. I could feel that move then. Let that cool before I let go. The next point I'm going to do is the one furthest away over here, just because of the warpage. Again, we'll get lots of solder there. I'll add some more to that one in a minute. Again, just push upwards a bit. Just try and get it nice and flat and straight. That's it. And we'll do these centre points. Nice beefy point there. Surprised how little solder was on those. It could lead you to think it's been taken off. I don't think so. I think it was just minimal from factory. There we go. So that's those dealt with. Still ever so slightly curved here, isn't it? It's at this point here. It's the point where the other side of the transformer. It'd be a good idea to reflow those as well, so I think I will do that. We'll just try and just push a little bit. Be careful not to break it. And the same thing, and the same thing here as well. Yeah, that's a lot better. Right, the next thing we'll do is straighten out that. So the way I'm going to do that is to desolder the solder points on the transistor there. So let's just get that solder off. It's got one point there. With an impact like that, it probably needs reflowing anyway, and lots of things around here may need a reflow. Let's just see if we can straighten it like that. Yeah, if you've got long legs like that, don't cut them down until you're ready to commit to soldering it back in position. It would help if the heatsink hadn't been riveted on, but anyway, that's that reflowed. It's a wee bit straighter, you know. It's still pointing a little bit, isn't it? We can twist that slightly that way. It's an interesting design, actually, doing that, riveting it on that way. It's a bit strange. The next thing are the two little resistors down there. Let's just measure these now. I have worked on a few of these, so if these are burnt up and you can't tell the size, you can work it out. Something like 4.7 ohm or something, if memory serves. They might not be. 47 ohm. That one's 47, and that one 47 ohm. You can get some of these power supplies where those are burnt up, completely charred. You know, you can't even tell what size they were. So that's useful information if you're in that situation. Now, because the solder is so badly oxidised here from being charred, you know, with heat, I am going to remove it, and we'll just re-solder them. There is a pad that goes in between those two, and that may lift just as a result of the heat damage that has suffered. So just bear that in mind. You may have to join them together with a wire. They join each other at this point here. So I've solder removed. Let's now add some new solder. Single-sided this PCB, so you don't need much heat. There we go. And then for good measure, we'll desolder the other 2 points there as well. It's really annoying this wants to flip itself over, this blooming board. It really is just because I've got the wires on the table here. If those were hanging over this way towards you, I've got a plug of solder I've just introduced there. There we go. Yeah, if the wires were overhanging towards the camera, it would be easier to work on. Consequence of filming. There we go. So yeah, when you've had an impact like that, you need to be looking around anything that could be affected. there is still some warpage here. Yeah, and I can always heat it a bit more. Anyway, I'll have another inspection around. Obviously we're going to clean up and stuff as well, but I think, assuming I don't find anything else significantly wrong with this, let's just trim that off, then I will probably give it a try. Put it in the plastic shell. Obviously we can't screw it in, but yeah, put it in the plastic shell and give it a try. So besides obviously cleaning this up further, the one thing I will do is order some caps for here, secondary side, and replace the caps over here as well, actually all of them. I'll just fully recap this, because this is going to be sold with the system probably, I think. And it will be safe to sell, because I've got the parts here. I'm going to fix these in such a way that they should be robust enough to hold the screw supports and things. It's fully fused and stuff. It's fused, you know, in two places there and outside as well. It's a solid plastic thing here. There are no metal parts. It's all right to reuse something like this. You may think not, but I'm darn sure it will be. So I think that goes this way around, doesn't it? Does it? I think that goes there. Yeah, that goes there. So I'm just going to put it in here to test. Yeah, just to avoid electrocuting myself, more or less. The only thing we need to do is just be careful with this main switch here when I switch it off and on like that. Do not touch that heatsink, whatever you do. It's probably DC. It'll be live. If you are working on something like this, like I say, take all the safety precautions seriously. Get yourself an RCD. If you don't wear a wrist strap while you're actually testing this here, because I mean, if you are, put the wrist strap on your right hand and use your right hand. Because the thing is, you may not realise, if say you got a wrist strap on your left hand here, yeah, and then you touch something with your right hand, that electric charger goes down your arm, across your chest, through your heart, down your left hand through your wrist strap. So yeah, it's simple stuff, but anyway, I just need to point some of these things out. Right, so it's plugged in, switch it on. Oh bang. So we're on volts DC here. I'll switch it on again. So it's on, and let's now try, if I can get the meter right way around, measure between these points. So we've got a ground there, haven't we, I think. Yellow, what's that? 0.3 of a volt. Oh, there we go, we've got 5 volts, look, 5.3 volts there. The yellow is not showing anything. That's interesting. Yellow might be something else actually. It might not actually be a supply. The yellow might be the I forget what it is now. There's a signal, sense signal, isn't there? The purple. Hang on, is I can get onto that. It's so hard to get the thing at the right angle. 15. Oof, the plus 12's a bit high there. So yeah, certainly something needs doing with regards to the plus 12. I think 15 volts is a bit too high for my liking. So the PCB's a bit straighter. At this stage here, you can see I've just super glued the first bit on there. Now that's not going to hold. That's not going to hold. If you're selling something like this, if you're going to use or sell something like this, as you know, it's a power supply, it would be a really risky thing to do without reinforcing this. So that is exactly what I'll be doing. Once that's set, I will scratch up the area on the surface slightly here with some sandpaper and stuff, and get a load of super glue and a piece of plastic right over, right round, right under, super glue on the other side, so that this whole area here is reinforced, and reinforce it in that orientation as well, and then just cut out a little hole out of the middle. You can use, you know, if you've got some thin plastic, plastic sheet, you could actually use that, and that's the sort of thing I'm probably going to use. But bear in mind, it's in a plastic shell. There's nothing in there for this to cause a problem. You know, if this was rattling around in there, yes, technically something like that could short there, yeah, but it's fused and stuff anyway. It's not a big deal, I don't think. I think it's okay. It's safe to, I would say it's safe to use. But yeah, don't take my word for that. I wouldn't repair something like this and then sell it. Yeah, what I may do with this is keep this one as a spare and sell one of the ones that's got a you know, properly formed PCB. I've shown this technique before. I had to do this on my Dreamcast because one of the power points on the PCB there was sheared off, you know, on the power supply, and it's been fine ever since. And just checking again, we do have minus 12 and plus 12. They're both a bit high, yeah. The minus 12 are low. Minus 12 is like 15, minus 15 that is, and plus 12 is plus 15. But you know what? I can hear it ticking. What that means is it's like switching, not switching, switching, not switching, because it's trying to regulate, because there's no load, I think. There's not sufficient load. So I think when this is under load, we'll probably see it more accurate in terms of the voltage. So I'm going to order some replacement 4,700 microfarads for these here. I think that one down there is either a 1,000 or a 470. But right now, I do have a capacitor to swap out the main smoothing ballast cap here. 47 microfarad, 385. This one's a Panasonic. It's CE series, 105 degrees, 400 volt, 47 microfarad. That cap's probably alright. These caps are probably alright, they're just aged, so we may as well do this here, give it a bit of love while we're here. So yeah, I'll clean up with the cotton bud to get all this fluff and dust stuff, clean the PCB up a bit, but swap this cap out, swap these three out here. I may retest at that point, just see how it affected the voltages here, but I'm guessing it won't affect them at all, to be honest. I think it is all about no load. And then when the caps to replace these arrive, we should be pretty much done. So I've still got two corners to glue back on, I'll do that as well while I'm replacing that cap. And then we'll strengthen those later. So I'll show you what I do. As I say, you could bleed away the power in a cap like that. Obviously make sure it's not plugged in, you don't want to be working on it when it's plugged in. Just do that. But yeah, I did measure it's like 0 volts. And obviously the other thing you can do is before you do that is switch it on. Because that will just empty that cap. But you can get a process, I forget what they call it now. Dave Jones covered this on the EEV blog, where you drain a cap like that. If you measure the voltage there now, you may find there's like 12, 20, 30 volts. It goes back up. Yeah, it can recharge even though you've just shorted it. So yeah, just be aware of that. As I say, I'm going to stick these back on, but before we do that, we'll get this cap. So let's just desolder that. We'll test these on the ESR meter, but I am making a guess now, an educated guess that they're going to be fine. I'd be very surprised if there's a problem with any of these caps. That cap should now come out of position, so the negative was to that side there. Yeah, so there was a bit of discoloration there, can you see that? So you know what, it was a good idea to swap that out, I think. So, same way around. So it's a smaller cap here physically, it's just a consequence of the technology getting better, I guess. And the good branded ones, these. The originals, maybe. I don't know what brand those are. Richie, yeah, no idea. But yeah, these are nice Panasonic ones. I think if I had them, I'd be fitting FR series. This one may be an FR series, actually. No, it's not, is it? It's a CE, I remember now. But yeah, it'll be more than suitable. I think for the 4,700s I was looking, and they're pretty blooming pricey. You know, on DigiKist, there's like £2 each almost. So what I think I'm going to do, I found a seller who's got some super high quality ones for audio equipment purposes that are Panasonic. They're slightly higher, 5,600. So I'm going to go with those. They'll be fine. Because all they're doing on the secondary side there is just smoothing the different rails. So a wee bit more capacitance based on the fact that they're super high quality grade capacitors, I think is a good upgrade. And the much cheaper is like £1.50 or something instead of £2 each. At least that is one capacitor down here, so we'll just trim off, and I'll clean the solder points up later when we clean the whole PCB. While we're here though, I spotted a long one there. Let's just get rid of that bad boy and that one as well. You know what, and that as well. If I can trim it, that's pretty blooming thick. There we go. Yeah, it's not especially exciting watching someone super glue things here. Let's just raise that up actually. Just stabbed a needle through my blooming finger. Yeah, it's one of these, you know, you try and unblock the tube. You need to be careful. Anyway, it's just a little bit like that. Yeah, and I know exactly what you're thinking. You're thinking this is never going to hold, and it won't, which is why what I'll probably do is, I was thinking about this, I might not just stick some plastic over there. I may do that anyway, but then stick down some washers. The key here is trying to get it to join at the right angle so that it feels like, hang on, it's joined up as it should be and not to your fingers. Right, on a messy workbench here, whilst that's drying, yeah, those two there are drying. I'm just going to have a clean up. They're pretty much dry already. I've touched them. You know, they don't move. They're rock solid. So, yeah, let's just clean all around this here. What I tend to do with those resistors there, the 47 ohm ones, is uprate them slightly. Those will be 1/4 of a watt. Put half watts in. And then they won't bake as much. The board won't bake as much either because they don't get quite as hot, but they are, or could be, considered a safety feature. But I think not. I think the Commodore just cheaped out with this particular power supply, and they just put cheap quarter watts there when half watts would be more resilient. Often they'll burn up those resistors. Often you can't even see what they are. The markings have gone off them because they've just charcoaled. Another thing you could do for longevity as well is replace this the opto isolator, because that ain't going to last forever. The LED, the emitting side of that inside eventually will stop working. It might not be as efficient, it might not be as bright, it could be dimmer, which means the power supply might get driven differently, the voltages could creep out as a result of that. Anyway, it's looking a lot cleaner now, I think. Compressed air would be a good idea as well. So the 3 smaller caps, we need a 470, and you check the voltage 22, so yeah, really easy to replace for me because I've got these in stock. So handily, the markings are on the PCB. Before you take any cap out of anything you're working on, always just check the PCB first so that you've got clues as to which orientation. The black band's towards the right there, which is the negative. You can see that on this one here. So anyway, that's 22. Let me see what the voltage is. Yeah, it's 25 volts, 85 degrees. So that's another thing as well. Sometimes they get hot, these power supplies. You can still see there's some warpage in that, look. So further work is needed to strain that. Anyway, let me see what I've got as replacements. Yeah, I've got some 22s there that are physically okay, 105 degrees. The FR series, they're higher voltage, 50 volts. Now, voltage ratings are obviously important capacitors, versus the 25 there. You may expect this to have a higher ESR as a result, but because they're super low ESR, it's actually lower than that one. So, they'll be fine. Another long leg there, look, it's sticking right out. Anyway, yeah, so the band wants to go to the right-hand side. Could just, push it up, spread the legs a wee bit like that, just to hold it in place. Technically speaking, that if you have a little bit of sagging like that we have here, that's a good thing, because then it won't be flat and flush with the board. It might just help with heat a little bit. But I wouldn't imagine those caps, the little ones there, to get that hot. But you never know, they may do. Yeah, solder points are looking a bit large there, but that is why I will always flow. That solder contains flux, by the way. I always get someone going, I can't believe you're soldering without flux. That's why you have solder with flux. But then when you get a bit of an odd-shaped solder point like that, that's where, after cutting the legs, just a reflow, and it will be to a point. You could even cut back further there, actually. Just get the solder off the tip. Yeah, that's not too bad. It looks a bit of a strange shape just because the way the legs have been bent through, but yeah, hopefully you can see the cap is on there. So I'll just do the same with that one, and that one was a 470. Again, 22 microfarad, 25 volts. Always check they're polarised as well. They will be on a power supply like this, but in some things you may find a capacitor doesn't have a band, and obviously that's important. And solder it into position. Obviously we'll clean the solder points up in a minute, but anyway, that's 2 down, just this one to go there. Yeah, that one's 470, 16 volts. Yeah, there we go. So yeah, other than just, I'm going to cut down 1 or 2 of these solder points around here. I think I'll start cleaning around that bit now with cotton buds. It's got this conformal coat, it's like a green gooey thing, so it goes all horrible. It's going to look a little pretty messy, I think, before it looks better. When you get charring like that, see how it's black, that's something to pay attention to, because if it's really blackened, you can get, it carbonises. So that needs a lot more cleaning. You can see it's yucky. I think one thing I would do as well is get some heat shrink over that. In fact, I've got the piece here we used for that wire, it's the same sort of thickness, but I think that one's not quite big enough. Yeah, I'll get a slightly bigger piece, I think, put it over there, heat shrink that. Just in case this heatsink should sort of slide around, it's not going to short. There's nothing else for it to short on there. You know, it can't short on anything on the transformer there. Ideally, if this was screwed on, you want to get some heatsink compound under that, but we can't do that without removing the rivet. I think it'll be fine, to be honest. Obviously, do inspect when you've been working on a board like this, so you've not knocked anything near anything where it could short. I mean, look at the legs on that. Wow, that's crazy long, isn't it? That could easily get bent the wrong way, but you know what? It's probably a good idea being high up like that. It's away from things heat-wise. Yeah, anyway, I'm comfortable we can test that, I think, as is. So, and these edges, they've sustained all the knocks and bangs and things whilst I've been working on that. What I did on the Dreamcast, you see, is got some glue or epoxy around there now and put a washer. Glue a washer on the bottom side. That might be what I do here. That might be okay, but there is still, as you can see, a curve here. I mean, it will straighten out once it's in the case. It's just a question of whether these can hold and sustain a screw going through once I've got a washers glued on there. And I go for those like plasticky washers because then it will adhere to the PCB really well with either epoxy or super glue. Right, let's carefully power it on again. Yep, no bangs or anything. Now I'm not expecting any changes to voltages here. I'm being careful to stay well away from the main switch over there. Where's the black? Black's there. So yeah, I think yellow is sense, if I remember correctly. Red, 5 volts, you can see there, 5.3. Yeah, so plus 12, you can see 15 volts. So the minus 12 is the white. You can see there, minus 15. But as I say, there's no load. So I think what I might do actually, before we get the caps now, is get a junk board that's got no Amiga chips, just got some 7.4 series. Just plug that in and see if the plus and minus 12 voltages level out somewhat. So as you can see, I've got a balked A500 plus board here. I mean, it really is balked, this, as you can see. And this I need actually for some of these parts here for another project. So yeah, I have no concerns if this board goes up in flames or whatever, because the ports won't. That's the thing, I'm going to need that port actually for something else I'm building. Anyway, and the hybrid, I need everything off this. So let's just get the multimeter ready. Yeah, so let's measure the 5 volt rail. I've got a bad ground here, so I may not get a connection. Oh no, 5.26. So the 5 volt rail is fine. And just moving things around a bit here, it's hard to get a good ground on this because all the grounds on this board are shot. Absolutely shot. I think the, there you go, minus 12 is minus 11, that's about right. Plus 12 is plus 11.3. So that's fine. That power supply is pretty much fixed. We just need to just clean it up, secure it properly with the mounts and the corners, and obviously replace the caps on the secondary side. But the issue there with the plus and minus 12 volt rails were just because it was under no load. Yeah, because what happens, you see, it's like I say, because you've not got load, it causes it to oscillate. That's why I could hear it making a noise. I might be able to demonstrate that in a minute. And I'll show you what, you know, a tool I have, just a piece of plastic tube really that helps identify things like that. It's always useful when you're trying to understand what's going on with the power supplies to have a piece of plastic tube nearby. I did talk about this in the 1084S repair video actually. Yeah, just a plastic tube, stick one end to your ear, and then the other end, obviously it's extended, it can actually move it around inside a power supply to hear what may be ticking or making a noise. And there was an example I might just cut in here. Yeah, so you can see the first piece of plastic glued over there. I'll do the same thing on the other side, but wrap it right over so that it's joined on the sides as well. Yeah, and then we can just simply cut out a hole in the middle. But then you could also get some thicker plastic and cut out our little slivers and actually epoxy. I'll probably do this, epoxy it here and here. Now I'm going to need to do that on the front ones because I'll show you. You can see on this side here where it's gluing, this here is copper. So actually I can scratch some of this off and join it up with a wire and some solder. And I can do the same where it's fractured on this side here, scratch this here, I have a wire, thick wire going across there and solder it in place, and then it'll be really strong at this point. And we can do the same with this one here, yeah, because it's copper all around it. That's a really nice way to strengthen it with wire and solder, not just solder. But the two down this side here are just plastic, that's all it is. But you know what, it'll be fine, I'm sure it'll be fine. So there you go, a little bit of scratching there, and you can see I've managed to expose the copper there. So we'll just add some solder there, and then I've got one of the beefy legs from one of those capacitors. It was the main one actually. Yeah, and we'll use that to bridge the gap, and then I'll do the same in that orientation. There we go, that's snipped off. And I could snip off a little further there, like up here. That's it. Yeah, so you can see we've got what should be a fairly resilient edge here now, but we'll do the same thing up here on this side as well. Of course, the further back you go here, the more structurally secure that's going to be. There we go, still looking a wee bit warped, but you can see I've managed to fix that there and fix that there. So it may need me to shave a little bit out of the corners, because you can see it's going to fit, yeah, on this edge here, and this has got to be almost flush, and it's going to stick up a little bit. So I may need to just get the file sort of in the corner a bit that way and a bit that way, just to make it sit a little bit lower on the two parts that are going to correspond with that. But the main thing is that is going to be really, really, really robust. Yeah, you know, it's been glued. The piece of plastic I took off, it's not stuck. Now, different types of plastic will stick onto different types of PCB. This kind of PCB, I can't get anything to stick onto the top of it. I may be able to epoxy. So that's probably what I'll do. Stick some epoxy around these points here, actually, just to see if that can strengthen it. But if it's secure on one side, I think the other side will be okay, to be honest. Because the mounts actually overhang. They were holding the board in. The board was not floating around because the mounts overlap on all parts of that there. So it's like it holds on this side, yeah, even if this broke off. So yeah, I think we should be okay. You can see I've marked these caps I've done here with the red dots, so we're just literally now waiting for these ones. As I say, I'll add some more epoxy, give it a final clean on the underside here, and we'll have a go at putting it back in the case. I've put a piece of heat shrink over that. Let me just show you. Just over this resistor here, right over the leg, so I've put a really large piece there. Just because I don't want this heat sink can rotate, you know, if it gets impacted. So anyway, I'm just going to shrink this down in this way here. It may not shrink to grip very well, but it will at the bottom. Yeah, that's holding in place. But a little bit of hot metal glue just at the bottom here, perhaps in between this cap almost, would be a good idea just to hold it. But anyway, that ain't going to short onto that. Right, let's test the caps we've took off so far. So I'll start with the big one. So this is the 385 I think it is. Volt one. 85 degrees again, you know, that's the thing with these, they were cheapy sort of caps really at the time. Yeah, you can see that's alright. 0.97, 47 ohms. For 400 volts, that's probably about right, and you heard it go ding ding, so let's check the 470, I think this one is. Hang on, make sure they don't short. Again within capacitance rating, 0.12, so that's fine. And this is the thing, you could be changing all these thinking you're going to make it perform better, and it probably won't perform any different whatsoever. But it may make it last longer. That one's really did need changing. 2.9 ohms is not good, actually. So the smaller ones, and you tend to find it's the smaller ones that are the ones that do need swapping. So you know what, that was a good one to swap without a doubt. And I'm guessing it's going to be the same sort of thing with this. Let's just try and separate those. Yeah, 2 ohms, not as bad as that other one, but it is still quite a high resistance. So some new capacitors have arrived here. These are uprated, obviously slightly larger, so yeah, there could be some challenges fitting these, but you should be able to do it, I think. And I'm going to remove all 4. We'll test them. This particular one, this is the first in a series probably, I think, of a number of power supply repairs here. Hopefully they're not all like this with broken boards and things. Hopefully we've got some varying faults. But yeah, I'll remove these, we'll test these. But if you were going to recap one of your own, I would replace all the ones around there. These ones here, they're pretty pricey. You pay like £2 or £3 per cap, so you know what, it's probably a good idea to just replace them all. But if you're trying to refurbish something like this and sell it, you're going to get nothing back for it. This will probably sell for very little, maybe 20 or 30 quid. and by the time you've added up the cost of all the caps and things, there's nothing in it. Do you see what I mean? It's almost like a pointless endeavour to replace every single one of these 4 caps here. Now what I mean is, you've got plus and minus 12 volts. The caps on those are probably going to be alright. It's going to be the 5 volt rail, if anything, that gets a lot of hammering. So you could, you know, skimp on only replacing 1 or 2 of these. I'm just going to have a measure around on connectivity. I think the red was the 5 volts, and we'll just, we might even be able to tell from here actually. Yeah, the red comes up here. So the red is that cap there. That's the 5 volts. And what else have we got? These 2 here are probably going to be for the plus and minus 12, looking at things. Yeah, it looks that way. So I'm not quite sure. We've got an additional one here. What's that on? Yeah, that's... oh, there's 2 on the 5 volt rail. Yeah, there you go. So yeah, there's 2 on the 5 volt rail by the looks of things. These 2. So yeah, on the upcoming ones, if it comes to the same model as this, what I'll probably do is remove and check these 2, but then replace these 2 even if they don't need replacing. But I'll show you in a minute, and there'll be a separate video on this. I have a bag of capacitors which I remove from things like this when I recap things, and you know what, like 98% of them are perfect, which is why I have a bag of them. You know, post Armageddon or something, at least if I manage to survive, I can find food and stuff. I've got a bag of capacitors here that could get me out of a pickle, assuming that anything electrical works after an Armageddon type thing. Anyway, you see my point though. It's like you could spend all your life replacing capacitors now, forever and ever and ever, and find that everything you replace didn't need replacing. Some of the capacitors for things in the 60s, 70s and 80s, the better quality than today's capacitors. Anyway, I'll leave you to fight amongst yourselves in the comments on that point. This whole recapping thing all kicked off really in the sort of, I don't know, mid to late 90s, where lots of SMD caps started leaking. You know, it was a bad... someone copied the formula, didn't they, or something, and it wasn't right. I don't know, lots of manufacturers started manufacturing cheap capacitors based on a formula that wasn't right. And you could argue it's about the form factor. Those little SMD caps, maybe they're more prone to leaking because they're so blooming small. But nevertheless, that is pretty much where the whole recapping thing has come from. You know, it's like most people just go, you know, it doesn't work, recap it, and he's recapping. It's like, no, 99% of stuff does not need recapping. There are some things where 100% of them need recapping, where those dodgy SMD caps have leaked. And they're through, you know, the original and the large can type like this, through hole ones. Yeah, some of those do leak, you know, certain manufacturers, certain batches, etc. But it's a lot less common than people are led to believe, that is for sure. I'm guaranteeing probably all of these are alright. I bet the ESR's fine on them all, and the capacitance. And obviously it will have a fair bit of use, this. But like on the mains side, yeah, the you know, here AC to DC and stuff, that the input side, you'd be foolish not to replace them, because in any, it doesn't matter what the capacitors are, they do generally get aged and hammered by the switching frequencies and things, and you know, just the way that those capacitors are used in that part of the circuit there. Yeah, so no signs of leakage there. We'll have a look on the board in a minute. So these are all the same, so I can just literally just whiz through and remove all of these. Capacitors obviously hold charge, so if you were to stick this straight into your capacitance meter, you may blow it. I mean, it's only a low voltage, the 16 volt, and the replacements, I'm not sure I explained here, these are really high quality audiophile ones, the Panasonic CE, but the CEXC, 105 degrees C, 25 volts, I thought there were 16 actually. There might be a 16 merged in here, I swear I saw 16 before. 5,600 microfarad. So yeah, just marginally more than the 4,700. Now I'm not sure this can go up to 5,000 or 4,700. I think it can. But I mean, look at the ESR there, that's pretty good already. 0.2. 4,870. I would say that that is going to be fine. But it's probably a consequence of the rail it was on. And I think one of these was on plus, you know, this is the next one. That was the edge one we did. Yeah, one of these is on the plus 12, one of these on the minus 12. And those rails get very little usage on the Amiga. They're used for the op amp, you know, for audio output, and they go to the ports on the back. I mean, that one's got ESR minus, so that could be a sign there. that there's something wrong with that. Let's just try that again. I've got to let you do this now. Yeah, so I'm not sure why that's showing 0.00. But we do know that the plus and minus 12 volt rails were alright on this when I tested it. So again, I would suggest there's probably nothing wrong with that. I think the large size of the capacitor there is what is affecting that the ESR reading where it's showing minus 0.0. Let's try one of these brand new 5600 microfarad caps. Let's see what this comes back at. Yeah, 0.03. So you can see the ESR on this is marginally higher than what those others are reporting, but we've got a lot higher capacitance there. 6,600. It's actually a 5,600, I think, isn't it? So yeah, you could question, are these capacitors better than these ones? I don't know. Certainly on the plus and minus 12 volt rails, I don't think you'd notice any difference whatsoever. But you see, the 5 volt rail gets an awful lot more usage. You know, there's a large current draw on the 5 volt rail. So yeah, you'd be stupid, I think, if you were servicing one of these, to at least, the very, very, very least, not replace the ones on that side and then replace the one on the 5 volt rail, or two, I think in this case, on the 5 volt rail. Same again, 4,700, it's another Ritchie, all the same. Yeah, so this one is definitely on the 5 volt rail here. Let's see what that one's coming up with. 0.03 again, same as the brand new one. 4,700. This is the thing, you see, so, you know, they're coming up as in spec, aren't they? Yeah, so slightly higher ESR, so you could argue that maybe that one was a good idea to swap out, but yeah, 4,930. So the negative band on these goes to the black marking there. It's perhaps worth paying attention to that when you remove the capacitor to start with, just in case it's been mounted differently, you know, different than it's actually marked, because yeah, that can sometimes be a thing. I've just cut the legs off there because there's a bit of sticky tape there, and I think that's going to stop them going through. And these holes, oh yeah, there you go, just right. So yeah, this one here is going to be a little bit tight. Now capacitors, obviously, you know, there's a relationship to frequency. So in some circuits you may want to you know, always ensure you fit the exact right capacitor. You know, it depends on the circuit. You know, so something like the ones down here, for example, you could have something to do with switching frequency. I've seen like 0.47 microfarad caps used a fair bit in power supplies, and there's a reason for that. It's about, let's say someone's calculated some frequency stuff and worked out that that's the size they need. But when it comes to things like this, smoothing caps, bulk smoothing capacitors that just supply, you know, that just acts as a reservoir for a rail, power rail. Larger, yeah, you're not generally going to have any problems. You get less ripple perhaps, and when you get current dips and things, you get perhaps slightly less of them if you've got larger capacitors. But there are lots of things to take into account. Things like this, you've got a choke here. Well, the size of that and the capacitor combined together can obviously change things. But yeah, anyway, we'll be good with this, I'm sure. These will be fine. There was a sneaky 470 there, but again, it did ding ding 0.4, so again, there's probably nothing wrong with that, but we'll swap it out anyway. So the final thing is to get a perfect seam all the way around. So just to file here ever so slightly, just to get rid of the little indent there, because obviously it's you know, it's epoxy here. You know, we've got epoxy on top and underneath and stuff, and this is the side, and this obviously is the side where it's reinforced with solder all around on the underside. So anyway, if we just move that heatsink out of the way, that goes on there nicely. Obviously we need to get the power switch like that through there, and if I can get it in, yeah, and then line that up, and as you can see, it's seamless. Yeah, so we can get the screws back in. I'll clean this up with a bit of IPA, get this tape marks and stuff off. We'll leave that on, whatever that is. Yeah, we'll just clean all these bits of muck and sticky things off it and give it a try. Rather than stick a sticker in here, I've just written on there 1st 11th 2022. So it should be obvious it's been recapped. Got the red dots there. I think we'll just draw some red dots on these as well. I'm probably going to keep this one as a spare and maybe use this actually on under my test bench. So yeah, all the caps have got a red mark, and we'll stick a red dot there as well, so it's pretty obvious. Right, we're almost there. So there are some yellow marks on this. You can see where the tape was, but all the tape's gone right up to the edge of that sticker. I left that sticker in place because that might be an original part number or something. It does say power supply unit for A500. So I don't know, that could have been like a third party sticker or something when it's been in for service or sales. But you can see it's pristine, it looks really clean. So yeah, there's the odd mark. I don't think I did that side actually, I'll clean that side next. But yeah, the cable, I'm going to clean the cable next. But the other thing, can you see this? There's a small chip there. Sometimes this happens on these, so you can see if I just grab that, you can see I can pull it out slightly. So I'm just going to get the smallest bit of super glue in there just to secure that down. But yeah, other than that, it's pretty good actually. Look at the dirt that's coming off this cable. I've got my foot holding the first part of the cable down here because I've cleaned that, and just go up and down like this. You can see the bits of dirt that just came off that top bit, and we can clean around that. Get a bit of contact cleaner into there, and yeah, just use a cotton bud, and yeah, it may need squashing down. You could just, of course, just insert it in and out of a motherboard socket. Can you see that though? There's marks. Yeah, you can get a lot of the dirt and marks off these with contact cleaner that way. Look. Yeah, I think you'll agree that was worth doing. Look at the dirt's come out of that. Looks like new now. There we go. Connected up to an A500 that you may or may not have seen on my channel, and obviously it's working. And as you can see, it's working fine. I did measure the rails there before connecting up to this 500, but yeah, it's good as new. So, well, better than new really if you look at the the additional smoothing it's got. But obviously it's been a bit worse for wear really, hasn't it, in terms of the PCB? But it's all held together perfectly okay. I think that actually got thrown into a skip. If you wonder what a skip is, it's like a giant trash receptacle. I'm not sure what they call them in America. Is it a dumpster? Yeah, at our waste recycling centres, people tend to throw things like this in there. I've seen them before now, and fished one or two out myself. But yeah, I think that power supply was lobbed into a skip, and the weight of the transformer is what smashed the corners off the PCB. But anyway, that is really good. Hopefully we'll have more success with the ones that are coming up, because I've got another 3 or 4, maybe 5 of these from different sellers, so we may have some different faults. So as you can see, I have been pretty busy. I've got 1, 2, 3, 4, 5 fixed there. This is the one we've just done in this video. You can tell because of the mark here. That edge there was super glued up there, and it just looks good as new. Yeah, there's a couple of little marks and things on it, but you know what? It is good as new. The cable looks absolutely brand new, pristine, super clean. Same with the coiled up cable there. Look at that. And obviously, internally there, it came up like new. In the light, I can actually see the pins look silver shiny. It gives really clean output on the 5, 12 and -12 volt rails there. Other things you want to do when you're checking a power supply is switch it onto AC and look for any AC ripple on each of those rails there, but I did that on this, 0 volts. I'm going to show some of these things in the upcoming power supply repair videos, and there won't be 1 hour-long video like there has been here for everyone. I might just like merge the next 4 or 5 power supplies all into one sort of 30 or 40 minute video with varying faults, and they have got some varying faults. And as you'll see in one of the upcoming repairs there, you'll see you can measure ripple on an oscilloscope as well. That's the best way of doing that really. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.